Danny.
Yeah, sorry.
Okay, so history is being made this morning. So over yonder, there's the old gray chair that I had taught and sat in since August of 1994. So 30 years later, that kind of gave up the ghost, and I got a new one. So you guys are witnessing history. It has armrests. It's kind of cool, you know, and it just didn't sound so. So if I have to
very
nod off
fluid.
during elections, because this chair is very comfortable. Okay,
I'm sure you got a massive chair budget. They're like, what chair do you
No.
want to pick? You have $1 million to pick any chair.
no, far from that. All right, so here's again what we tried to talk about yesterday with work.
Tried to talk about.
Tried to. Work by itself is the easiest calculation in the world. It's force times distance. But it's the most screwed up calculation that we have in spite of its simplicity. Because this force is only in the direction of motion, okay? So if you're pulling a block and you've got gravity and you've got force normal and you've got some force applied and you've got some force friction.
Oh, nothing's showing.
Well, that's weird. Hold on. It's showing on here. There we go. Okay, thanks. All right. So when you're pulling this thing, gravity and normal are there. Don't worry about it because they're not in the direction of motion. And here's, and you'll see this especially when we get into thermodynamics. This is I really like this chair. I was like, I feel kind of, like I feel like I feel like I should have like a pipe, you know?
Please get a bubble pipe.
Huh?
Please get a bubble pipe.
Yes.
Oh, might have to do that. Okay. So,
That would
or
be
at least
so
like
cool.
I should have like a smoking jacket on and like a fireplace behind.
Yes.
Okay.
For Christmas, we move the shirt and we just print out a
Put a
big
little
fireplace.
back there.
Yeah.
Yeah, get a little stuffed lab or something to lay on the floor. Okay, you're gonna set the theme.
Little
Yes.
stockings.
Yeah, little stocking. Oh, everybody can bring in the little stocking.
And we can put various things in them over the course of.
Coal. Okay.
Like our sadness and failure.
Your tears. Dry Kleenex from the tears. Dry. Okay, anyway, back to our story. The 12 days of sorrow for Christmas. On the first day of sorrow, my physics teacher gave me one failing grade. Okay,
And an
so
assignment to do in an hour. On the
there's no
second
calculator. Okay, so
It
anyway,
takes
so
4
back to our
hours,
work
is the real
story. So, your gravity and normal, not part of the story. The only time you'd worry about these is if you were lifting it, okay? So again, it's only the force in the direction of motion. And work can be positive or negative, and it has its own little set of quirky rules. So, if the force is in the direction of motion, or you're lifting it up, it's a positive value. If it's in the opposite direction of motion, like friction, or you're lowering it down, it's going to be a negative value. There's no mathematical justification for it. It's just like, hey, this is how we're defining the values. So, with that said, if you look at
I might just put that on.
question number 4, okay?
Wait.
So, if you have an inclined plane, then that kind of creates its own little wonky problem.
You know, it's not working.
So let's say that you have, and the other key assumption about this is that it's a frictionless surface. So this is what we talked about yesterday. Since work is force times distance, you can either just lift something straight up. If you have a longer ramp like this, that's going to be your force parallel times your length. If you even have a longer ramp, that's even gonna be a smaller force parallel, but you're gonna multiply it by a longer value of length. So if there's no friction, all three of those would be the same amount of work. Because if you look on a force distance graph, here would always be your trade-off. Big force, small distance, smaller force, longer distance, even a smaller force, a greater distance. But all three of these areas would be the exact same. Now, that's if you're neglecting friction. If there's actually is friction, you do less work in just lifting it straight up. If there is friction on an inclined plane, which there is, then you actually have to do more work because not only do you have to overcome the force parallel, you also have to overcome the frictional force. Okay. Your answer to number 8, because if 8A is wrong, everything is going to be wrong. That should be a not so good GPA times 10 to the 5th joules.
Yeah, that is pretty terrible.
Yeah, it's pretty terrible.
That's really bad.
B and C are both 10 to the
Uh-oh.
3rd on number 8. You should have like maybe some negative answers on this assignment. If you don't have any negative answers, something has gone wrong. Okay? And just don't randomly go through and make them negative.
Yeah.
So if you
Yeah.
look
Is
on
it negative or positive?
question number 10, okay, on mine. So
Positive.
if you read
Oh, wait, that
question number
should make
10,
sense. I just put it as negative. You did say something.
Nothing makes sense.
you've got a block slides down an inclined plane at a constant velocity. So here's the story. So since the block is sliding down, right?
Right.
Okay, block is sliding down.
Mm-hmm. It goes.
Okay.
What about the yellow?
So what's the direction of motion?
Down.
Down. Okay.
But if you need it, just ask me.
But it's sliding down at a constant velocity, right?
Right.
So here's the story. So since it's sliding down at a constant velocity, what's the force that's trying to drag it down?
Force parallel.
Force parallel. So the force that you have to apply is balancing out that force parallel. So this is a situation where the direction of motion is down, but the force that you're applying to keep it from accelerating is acting up. So your force acting up is in the opposite direction of motion. Since it's in the opposite direction of motion, that needs to be
Negative.
a negative value. On number 11, make sure that you have given some mathematical justification. So on 11A, obviously, B is going to travel further, okay? What you need to say is why. You just can't say, well, B has a smaller acceleration or bigger acceleration or something like that. That is not a justification. You need some kinematic equation that says, hey, this is why that answer is what it is. Okay? On the problems out of the book, so let me kind of point out some potential pitfalls. So when you get to those problems, page 311, on question number 3. So when you look at that diagram on number 3, so you got 500s going this way, and then you've got these forces like this, and that's 326, and that's 223. So again, here is the story, and I know I said this, but it's the most common mistake that's made. So how much work is done by each of the ropes on the crate? So are you going to use the entire 326 value
No.
in your work calculation?
No.
No, because that's going in that direction, okay?
The only one,
Yeah,
distraction.
so the only force that you're gonna worry about are the forces that are in the direction of motion, so you gotta do some trig to figure that out,
Can I see what you got from?
okay? On the book problem, number 6, it's that kind of in terms of a diagram. So on number 6, you've got an inclined plane that's at a 20-degree angle,
Yeah.
and you're told that to keep the crate from sliding too fast, page pushes back on it with a 68 Newton horizontal force. Okay? So that 68 Newtons is here.
Oh, see it.
Okay? That's your 68 Newtons. Now, are you gonna use the 68 Newtons?
No.
No. You're gonna use the component of that 68 Newtons that's acting along the inclined plane. Okay? So,
Oh, I did that weird. You did it not right. You didn't take the force parallel.
Yeah, I
just did the
so
force
on
because
number 6,
my brain was like,
you, when you get done, it says how much work does this page do on the crate if it slides 3.5 meters down the ramp. So, that answer should be between 50 and 100.
Okay, I know I got the force wrong, but I can't.
No, the overall answer, I'm sorry, the force was between 50 and 100. Your answer on how much work she's gonna do is between 240 and 280. And gap, Sean, I'm sorry if that's too big of a gap for you, I don't care.
This is for 6, right?
this is. Wait, which number was that
What
one?
answer did
Four.
you just call it for?
Number 6.
Okay, I did call.
On problem 2 out of the book, 2 of your answers should be times 10 to the 3rd, and 1 answer should be 10 to the 4th.
Yep.
Yep.
Okay? All right, anything else? Once?
Yeah.
What?
11B.
Huh?
11B.
On which one?
Uh,
Mine?
yes, the yellow paper.
Okay. So it says, which object has the most work done on it, right? Does work equal force times distance?
Yes.
Is the same force applied to each object?
Mm-hmm.
Yes?
Mm-hmm.
So the one that travels the greater distance
Has more work done on
has
it.
more work done on it.
Got it. So B.
I'm just telling you.
I'll
You
go-
figure it out
I'll
from
go
there.
with B.
I'm just telling you. You figure it out from there. Danny?
For like determining as work is positive or negative, how did you want to do it? Because I remember yesterday from the lecture, you said that sometimes work is described as positive if it's helping for gravity.
If it's, here's the story.
Okay.
If the force is in the direction of motion, okay? So if you look at like the work that I do, let me take this block, okay? So if I lift this up, let's say this thing weighs 5 newtons, okay? And I lift that up, and I lift it up 1 meter, okay?
Okay.
I would do 5 joules of work. Now, if you look at the work done by gravity, because gravity is a force, okay? So if it says, oh, how much work was done in overcoming gravity? So the gravitational force is acting down.
Yeah.
So if the work that I would do would be a positive 5 joules. The work done in overcoming gravity would be a negative 5 joules.
Oh, okay.
Now, if I lower it, okay, my force is exerting upward, but the movement is down. Now, if I lower it, I would do the negative 5 joules. That gravity is in the direction of motion, and gravity would do the positive 5.
Oh, good.
Okay, does that make sense?
Yes.
Okay. I like my chair. All right. Anything else? Once, twice, sold? Okay. So stop me on the camera.